Okay, let's begin today by just sort of reviewing what we've already talked about. You guys have this little checklist from Tuesday, I think, right? Okay, so let's just sort of have a quick peek and see what we've covered already. Have I defined the gravitational field qualitatively as a region of space around a mass or another point mass experiences force? Yes, I know that was in the notes. Basically, I told you what a gravitational field was. Did we diagram the Earth's gravitational field using lines of force? I did. We did that yesterday. Remember the lines point towards the Earth? The page over there after we sit down? Page in the back. We did diagram the Earth's gravitational field using lines of force. Remember this one? Remember that? I think we also diagrammed the Josh's gravitational field. Got deleted. Did we define the gravitational field quantitatively as a force per unit mass? Yeah, I remember kind of talked a little bit about that. Have I talked about the difference between mass and weight? I think I briefly have, but I haven't done it formally. Have we talked about apparent weight changes in vertically accelerating systems? Not yet. Look forward to that one. Have we derived the acceleration due to gravity from free fall of Newton's laws? Not really. That's kind of a weird one. Have we performed an experiment yet? No. Have we solved free fall problems? We will. Have I described terminal velocity qualitatively and quantitatively? Certainly, I told you what terminal velocity is. We watched the videos. The sewer is falling out of the sky and the penny drop. Have we defined the coefficient of friction? Not yet. No, not yet. No, not yet. Not yet. Not yet. So we've actually covered quite a bit already, haven't we? Okay. So, you will need to remember those formulas. Before I begin, do you see any mistakes? Is what, Dan? This one right here? Is there something wrong with it? Right? V bar, I have no idea why that mistake is in there. Is this one right? V bar equals, I thought it was VI minus VF over 2. No, averages add them together. This is change in velocity, right? Those are the ones that you're going to need. Basically, like I said before, we're going to take all those horizontal problems and put them vertically. Okay. The demon drop is a ride at an amusement park. It sounds scary. You watch it in time its free fall time at 1.5 seconds. You've probably never done that. How fast is it going when it reaches the bottom, and how high is the ride? Okay, what do we know? The time, 1.5 seconds. That's all we know. That's all they give us in the question. We have acceleration. Well done, Dad. The acceleration is minus 9.8. Quite often that will not appear in the question. You just have to know that it's happening. Okay, so how fast is it going when it reaches the bottom? What did we also know? It's initial velocity, or we can assume it's 0. Have you ever been on one of those rides where you're up there and they just let you go and you fall? That's what we're talking about, right? Okay, so what am I going to do? What do I need to find? How fast is it going? I'm solving for VF, right? What do I do? Well, with t and a acceleration and time, a and t, what can I get? Are you starting to find that you can sort of see that path thinking forward a little bit? I hope so. I have to say, you guys are doing a great job of writing your solutions. All the tests that I've looked at, the solutions are nice and neat and they're lined up, and you guys are doing an outstanding job. I would say the best I've ever seen, actually. Everybody get minus 14.7? Pretty straightforward, right? So what is that? That's how much the velocity changes, right? Now, because the initial velocity is 0, that means then that the final velocity is minus 14.7, right? I think we are now at the point where you can just leave that part out and just go like this. But remember, that's only true when what? When what happens? The initial is 0, right? Only true when the initial is 0. If the initial is anything else, then you're going to have to show this and do the work. So subtraction. Don't forget. Okay, so that's part A. How fast is it going? It's going 14.7. How high is the ride? Well, it's probably really high because it's scary. Can I just go V equals D over T and just put 14.7 in there? I see a few people shaking their head. How come no? How come, Reese? Because, yeah, this is average and this is final, and they are not the same, and there are a few people who I wrote that on their test. But you'll get back on Monday. You have to find the average first. Right? 0 plus. Now, should I go minus 14.7? Okay. So I'm adding minus 14.7 all over 2. Minus 7.35 meters per second is the average. And now I can plug that in over here. And you get minus 11.025 meters. And I'll just pause there for a second and I'm going to ask you a question. How come it's minus 11? Shelby, do you know why? No? Austin, why is it minus 11? No? Well, I mean, I guess the obvious answer is because that's negative and that's positive, and when you multiply positive and negative, you get negative. But Morgan, why? Is that what you were going to say? Well, that's true. Now, should this be minus 9.8? Like, where did the negative come from? Braden, should this be minus 9.8, the acceleration? Yay or nay? Multiple choice. Yay? You're going to go with Dan? How come? Oh. Minus 9.8. Down, why is it negative? Because it's down. And is the change in velocity negative? Yes. And is the average velocity negative 7.35? Yes, because it's down. And this D doesn't really stand for distance. It really stands for change in position or displacement. And what are you doing when you ride this ride? You are falling down, right? So this negative 11 is really the displacement. It's how far your change in position is. Technically, that means the height is 11.025, right? Now, am I going to get all excited about that? No. But what I wanted to point out was don't worry that this is a negative displacement. In fact, when you get to grade 12, and you're all taking grade 12, right? And we start throwing things off cliffs that are, say, 100 meters high, the D, the displacement, is actually going to have to be negative. Okay, so that's why I sort of introduced that there. Good? Yeah, makes sense? Avery, did that make sense? Did I speak English? Excellent. Do you want to try one on your own? Not yet? Fair enough. A tennis, this is your example too, right? I hope? Because I changed the order of these one time. Yeah? Okay, good. Tennis ball is thrown upward with an initial velocity of plus 22.5. It's caught at the same distance above the ground from which it was thrown. How high does the ball rise? How long does the ball remain in the air? So here's the person throwing the ball, again with the really long torso. Right? So what I mean is, when I say it's caught at the same distance above the ground from which it was thrown, is don't worry about That little distance there. Don't worry about that.
So his hand is 0.
Okay? Hand is 0, catches it in his hand. Let's put a 0 there. So the initial velocity is 22.5. Does it matter? Does it have to be plus 22.5? Taylor? Does it have to be plus 22.5? Yeah? How come? You don't know? It goes back to what we just talked about with the negative. Alex, do you know why? Why does it have to be plus 22.5? Don't know? I'll give you a hint. Why does it have to be plus 22.5? Because it's thrown up. The velocity is up. It is important here. Okay, it's kind of the same. This is how high does the ball rise? So we are solving for, Brody, before you sit down, the pages are back there. We are solving for the displacement up. Now, from what we know before, we should get a positive or negative d value there, Brady. How come? You know I'm going to ask that. Because it's up. Stay with me, man. You'll learn something. It's thrown up. Okay, so now, would you agree that the distance up is the same as the distance down? Pretty much has to be, right? Distance up must be equal to the distance down. Okay, now we also know acceleration is minus 9.8. Now there's one other piece of information that is not given, but you know it. You just don't realize it. I'll give you a little hint. I'll give you a bigger hint. The velocity is 0 there. The final velocity on the upwards part of the trip, the velocity at the top is 0. Okay? You all know why, right? I mean, it goes up and it comes down, right? It stops, exactly. Okay, so you don't know that, it doesn't tell you that, but the VF at the top is 0. Okay, so I want to know how high does the ball rise. I'm going to have to use the displacement formula. V bar equals d over t. I don't have V bar. Can I find the average? Can. Let's find the average. Initial, 22.5. Final is 0. Divide by 2. 11.25 meters per second. 11.25 meters per second. V bar equals d over t. Oh, got a problem. What's the problem? Don't have time. Acceleration minus 9.8. How much does the velocity change? It goes from 22.5 to 0. Automatic arithmetic. Except we got a problem. Can you have negative time? I did see Mr. Friesen in the building today. You guys don't know the Mr. Friesen story, do you?
I do.
Okay, so anyways, Megan, what's up? Megan, sorry.
Isn't acceleration always negative?
Yeah. Why is the acceleration always negative? Because it's always down. Where's the mistake? That I had made a mistake and I purposely made it. Some of you may have noticed that I sort of did an extra long pause there. I was kind of waiting for someone to point something out. Like, can you have negative time? No. So there's something going. The negative 9.8. That's what you're wondering, right? The change in velocity. It went from really VF minus VI, right? 0 minus 22. The change of velocity should have been that, right? So that makes that, right? So the reason I do that is if you get a negative time, it likely means what? You've made some sort of error somewhere previously, right? So if you do get a negative time, stop and think about it. How much do you think that question would be worth? Well, 1 there. 4, Josh? Really? Where do you see the, like, okay, maybe 1 for this. This is all 1 step here. Not likely. Yeah, that's it. Oh, yeah, we haven't finished. How high? We're really trying to find how high the ball rise. Oh, okay, yeah, we got to finish. There's another good tip. Always reread the question before you think you're done, right? I didn't follow my own rule. Once again, Josh was right. Way to go, Josh. So the displacement would be, now I have to multiply those two together, 25.8. Meters. 25.8. Just to make sure, let's reread the question. How high does the ball rise? We did that. B, how long does the ball remain in the air? Oh, is the answer 2.3? Well, the sheets are at the back there before you come this far. Is the total time 2.3? How come? That 2.3 is just the uptime, right? So the total time would be 2.3 up plus 2.3 down. Fine, well? Yeah. 4.6. Is the time up always equal to the time down? The distance up is the distance down. This is only true when air resistance is ignored. Only true when air resistance is ignored. We have done the first 2 examples. Have you done questions like this? X plus y equals 4, x minus y equals 10. Remember doing those systems of equations? I'm going to show you an application. Please don't freak on me. Canada's Wonderland has a drop ride that's 230 feet tall. That is true. I've seen it. How fast are you going when you reach the bottom of the ride? How long does it take to reach the bottom, assuming free fall? I hate to admit it, but I stood there and I watched it, and I timed it because I wanted to know how tall it was. And then I went home and I looked it up, and I was right. Yeah, I'm a bit of a nerd. Okay, first problem is what? 230 feet, right? Now, we can deal with feet if you know, and you don't need to know this. Please don't run home and say, Mr. Bennett expects us to know this. But acceleration in feet is 32 feet per second squared. You don't need to know that. Probably the easiest way to do this is to convert 230 feet to meters. And in Canada, you would expect that. I have absolutely no idea why this question has the answer and has the question in feet. But if you run across something like this, you know, this is how you do it. You get out your phone and you type in 230 feet in meters. Go ahead. How many meters in a foot? And how many feet in a meter? About 3. Did you get 70.1? Okay, Braden, here's the learning part. You know, listening, engaging, because you know I'm going to ask you a question to see if you're paying attention. Should it be negative? How come? Because it's going down, exactly. The displacement is minus 70.1. Okay, how fast are you going when you reach the bottom, and how long does it take to reach free fall? We also know acceleration is minus 9.8, and we know that the initial velocity is 0. Right? How fast are you going when you reach the bottom? We want VF. Any ideas what to do? Oh, not 0, sorry. Whoops, by mistake. If I go A equals delta V over delta T, that's not going to help me. If I go V equals D over T, eh? The 70.1 is the 230.
Oh, I thought it was 7.
Oh, yeah, that's a question mark. Well, let's just start writing and see what happens, right? Okay. I got to make sure, I got to be careful here. V bar equals D over T. That we know. Do I know the average? I don't know. I don't know the average. I do know this. Can I solve that? Can't. How come? I got two variables. But remember, you guys solved questions like this, right? Is there not two variables there? How did you do it? Here's an equation with two variables, x plus y equals 10. You got another one. There was two ways to solve questions like this, right? There was the add them together, right? 2x equals 24. And I apologize for those of you that haven't seen this yet in math. You're getting a preview of the joys of system of equations. That was one way to do it. The other way was by substitution. I usually try to wait on this kind of stuff until you've seen it in math. I need another equation with v bar in it, right? Or another equation with t in it. Do you know another equation with v bar in it? Yes, you do. You know this one, don't you? Right? You know what? Put your pens down. Just watch. What's the initial velocity? Would you agree that v bar is equal to the final velocity divided by 2? Would you agree with that? I see a few nods. And would you agree that this v bar and this v bar are the same? So can I take this df divided by 2 and plug it in there? I can, because it's the same. So now I've got vf over 2 is equal to minus 70.1 over t. And I didn't do anything good because, Braden, I still have two unknowns. This is a challenge, by the way. This is a challenge question. There's no doubt about it. Don't worry, I'm not going to expect this on day one. Do I know A equals delta V over delta T? Well, I know that formula. And I know that A is minus 9.8, right? And don't I know that delta V is what? Is that not equal to VF minus VI all over, we'll just call it T. And do I not know that the initial velocity is 0? Now, what have I got here? Oh, that's not a 2. Someone's paying attention. That's good. What have I got now? I have an equation that has what in it? VF and T. And here I have an equation with VF and T. Is that the same as x plus y is equal to 10 and x minus y is equal to 14? Same idea? Two equations with x and y's. Two equations with VFs and T's. They're just looking a little less nice than these ones. So what do? Well, I like to go by substitution. So I'm going to isolate VF here, and I'm going to write VF is equal to minus 9.8t. Again, don't freak out if you can't do this. This is a challenge. Now what can I do with this VF right here? System of equations. So I'm going to put minus 9.8t all over 2 is equal to minus 70.1 over t. And what did I just do? I got rid of the VF, and now I have an equation with only t's in it. And yes, your algebra skills are being put to the max here, aren't they? Camel, how do I solve this one? Don't know? Anyone? Multiply both sides by t. T goes up here. Minus 9.8 t squared is equal to 2 times minus 70.1. And so on. And I'm gauging by the looks on the faces, and I think I might just stop. Should I stop, Rudy? No? Do I know the answer? Maybe I'll just finish it. 3.8 seconds is your answer. Okay? Don't freak on me. I'm not expecting you to do that. Yes, I'll scroll up. Okay? I'm giving you a little preview down the road a little bit. Yeah, it's a little harder than grade 10 science, isn't it? Grade 12. We definitely do questions like that, grade 12, for the system equations. Not a whole lot. They stick up every once in a while. There's about 4 or 5 times when they pop up. Okay? So I'm just giving you a bit of a preview there. I'm going to remind you that you have a problem pack here. The front page is like just thinking theory kind of problems. Starting on the back page there, problem number 1. Actually, problem number 1 you can't even do yet because Joe's standing on a bathroom scale. So you're going to have to leave out number 1. These are just sort of assortment of problems. I should really organize them a little bit better. The answers are there on the back. The solutions are there. I think based on when I look at faces and when I look at these questions, I'm going to give you another set right now that's maybe a little bit simpler. I will say this. You must be able to do, please make sure, go to the second page here, question number 7 on this problem pack. Kyle is flying a helicopter. Put a big star beside those. Okay? These are from yesterday. Okay? Should be back. Oh, I know it's over here. Those Kyle flying a helicopter questions, they are important. Okay? Make sure you can do those. 7, 8, and 9. Okay? I'm going to leave you the rest of the period to do some work. Okay? And I'm going to get that other set maybe easier one day. Sure. I think Monday I said I was going to go through these front page answers, right? Yeah, so please do those for Monday.